Okay, so the panel is Infra powering Solana. So really excited about this one. So let's kick it off, guys. Maybe Mitch, starting from you, a quick intro, your name and what your project is doing.
Cool. All right, this is loud enough? Perfect. Cool. So yeah, I'm Mitch. I am CTO of Switchboard. We've actually been around on Solana since April of 2021. We've been actually since the start, the first Oracle, but we've actually done a lot of the traffic on Solana. I think for the first few years, we had a few different iterations of oracles. The first model was a push oracle. We did 3 to 7% of the traffic for a very long time on Solana. Then we've actually moved to this on-demand system, which is much more efficient to allow the scaling of Solana really flourish. And since then, we've grown to really support a lot of the Solana ecosystem. And I'll leave it at that to give more detail.
I love the mascot as well.
He's adorable.
Hi, everyone. I'm Andre, or as many know me, Andre from LeFi. I'm the head of DeFi. And LeFi is a price comparison API that offers best price execution on chain. We aggregate different liquidity sources from bridges, DEXs, DEX aggregators, solvers, all into one API. And different partners use this API to facilitate swaps from one chain to the other. For example, from Ethereum to Solana, we are powering swaps in all the big DeFi wallets and DeFi blue chips. So I like to say that if you ever done a transaction in DeFi, it is very likely that you've used LeFi under the hood, either in Hyperliquid or in Phantom Wallet or in MetaMask. You definitely interacted with the LeFi smart contracts at one point.
All right, I'm Austin Federa. I'm one of the 3 co-founders of 00. We are building a physical fiber infrastructure network for high-performance blockchains and other types of distributed systems.
Hey guys, I'm Rashid. I lead APAC strategy at the Wormhole Foundation. Wormhole is an interoperability platform. We do a lot of different things. Core thesis, we help projects go multi-chain. Fun fact, we were actually the first Solana to ETH bridge back in the day.
Awesome. And quick intro on my side. So I'm one of the partners with Borderless. One of the funds we run is the interoperability fund, working very closely with Wormhole and investors in a bunch of Solana startups, including, by the way, 00 as well, along with Parena, Solayer, and a bunch of other companies. So maybe let's jump in. So each of you is working in a different layer of the stack, right? From networking, liquidity routing, oracles, messaging. So since this is the Solana snapshot, right? What makes whatever you are building on Solana different as compared to other ecosystems?
So I'll just give some background here too. I actually ran a network security team at Google for 2 years before I joined this. I had a team of 3 people. And the core crux of what I did was we had this whole stack for App Engine, which had a totally different networking layer than everything else. We had to basically make these connections for 2 different systems and combining these things. And it actually carried over to how you have to deal with blockchains, very decentralized different systems that you have to actually coordinate in a very, very efficient way to optimize speed, especially for any DeFi. And really what you come to see is when you have these fidelity systems, these high fidelity systems, you now have these institutions that are coming in that want to trade at the speeds that they're used to, and they have their very competitive logic that comes with that. So how do you actually keep this a fair playing field for any trader and institutions? And the way you do that is you can actually offer these systems that offer these fair access to pricing to actually swap these assets for, any amount that they need, and making sure this is a fair play system for everybody involved. And how you do that is actually making sure that data is a free range system. So we want to make that as accessible as possible, not so any business has to pay $300,000 a month to get this access so they can beat certain traders. But we want to actually make sure that this is the best experience for everyone and also leads to ultimate safety of these contracts. Mostly being things that actually really require high fidelity pricing, like perpetuals, rather than this other side, which is you need these baseline pricings periodically for things like lending. So when you come to high fidelity, it really comes to things on chain that come down to perpetuals. But now you see a lot of AMMs that are becoming Oracle-based AMMs because they want to actually swap to liquidity that's off-chain. that institutions are actually bringing on. So you're seeing more and more AMMs actually look at this Oracle-based system for pricing swaps. And with that, a lot of solvers come into play on-chain as well.
Andre, maybe.
Yeah, so I mean, for us coming from the EVM landscape, Solana was very new, and Solana as a monolithic architecture is a lot more predictable and precise. However, it comes with, different constraints. Like, for example, we solved for bridging initially through the Phantom wallet, but then we realized that, okay, we need destination swaps on Solana as well. So that comes with a hurdle that we didn't had in the EVM landscape, that, okay, here it's a bit more complicated to actually scale up the transaction and have a destination swap on the final destination chain. So for example, on the EVM landscape, it's easier, let's say, to have a swap bridge swap and a contract call on the destination chain. And by a contract call, I mean you have money on Ethereum and you want to repay your loan on Arbitrum on Aave. Now, for Solana, it's easy to do just the bridging part. But if you want to have a swap and a bridge and also a swap and the contract call on the destination chain, you need to actually readjust your whole technical architecture for the monolithic type of architecture that Solana has. So a lot of learnings. It was a pretty steep learning curve for us, but now we do think that we are pretty up to speed with everything on the Solana infrastructure from a perspective of what we're offering to the actual end user that wants to, swap on Solana.
I'm actually going to start kind of from the top of the stack and go down to where we actually interface with it. So I think like Mitch said something interesting, which is they switched from a push model to a pull model. Pith also switched from push to pull. And that's actually a failure of Solana. There's a lot of like good reasons that it makes it easier to charge for an Oracle, but fundamentally that's because transactions on Solana got more expensive than they were in the beginning. And we haven't actually seen base fees come down on the network as there's been more and more demand across the network. And so like we built on Solana a validator client that can do 1 million transactions per second. This is called Firedancer. The Agave client can also do an extremely high number of transactions per second. We don't see this actually in reality today, though, because the communications bottleneck is the thing that's preventing these networks from actually hitting these type of throughput numbers. And so that is what we are addressing and building, right? And so with physical fiber infrastructure, this is dedicated fiber, not shared public internet infrastructure. This can move much more quickly than you can use over the public internet. And so one of the real things we are trying to solve is to take the bottleneck back on the software team, right? For years, blockchain was held back by the fact that EVM is slow, these clients were very unoptimized, Solana was super buggy. Like there were all of these reasons from a software standpoint that you couldn't get higher transaction throughput numbers. But like pick your favorite chain that's like not Bitcoin, and you can download the validator client, run it locally, and you can get orders of magnitude more performance. Or you run it on a testnet cluster in GCP or bare metal, you'll get orders of magnitude more performance than you get on the mainnet. And that's not just because mainnet traffic is more complicated, although that's some of it. There's a huge amount of communications overhead that goes into making these systems actually work in the real world, and the internet's just not built for that. And so we're starting from the lowest level, which is like, what if we just rebuild the internet to be faster and better suited to high performance distributed systems?
Yeah, and Rachit, before we move to you, Mitch, you wanted to...
Yeah, no, I actually very much agree with everything that Austin said. I just wanted to add one comment, which is what we saw for the slowness when we're actually committing prices was really the lack of distinction between the state layer on chain and the execution layer. Because being an Oracle, all you do is deal with state. We have over 2 billion price updates we did over the first year and a half that we ran Switchboard. And what we really noticed was the problem with contention with right locking on chain.
Yeah.
Because overall, it is a database in some sense. People joke with SQLana, but like if the programming model is kind of similar, it's very more decentralized and has all of the necessities to make sure that is non-reputable. But yeah, it is. You still have to maintain the logic of read-write locks, which are very basic multi-threaded system building blocks. So I would love in the future of Solana to see a better system between the state and execution layer, which would go down a system of better control of who can hold write locks on accounts. But that's a very technical solution.
Rachit, you're like, what does make just repeating the question?
Yeah,
what
no,
does
I got the question. As I mentioned earlier, Wormhole was the first bridge from Solana to ETH. A lot of what we built has been with the foundation. I've only heard stories of Austin and the team jamming together. What we are building now is Wormhole settlements. It's essentially an intent-based architecture where the base layer is Solana. So think about intent-based architectures traditionally. Solvers have to rebalance between different chains. What we are building right now is the solver doesn't need to rebalance; they can just rebalance back to Solana. So that's inherently something very interesting coming onto the Solana ecosystem.
Awesome. And maybe starting with you, Rachit, again and going this way. So what does low latency really mean on Solana? Like, how does each of your projects help improve the experience for users, apps, to make them more faster, more reliable? Yeah. Maybe let's start with Rachit.
I think for us, I think liquidity is like I know that's low latency, and Austin will probably cover that better than I will. But for us, the bigger thing is like whenever we talk to a Solana dev, they inherently don't want to go multi-chain. Austin, like they'll essentially say like, "Hey, we're on Solana." They won't understand. The user education on that side is more, "Hey guys, you actually need to build multi-chain so that you can actually get liquidity from other chains, and it'll help you. It will eventually help the Solana ecosystem." So, um, in terms of how we help users and dApps, it's more on the liquidity side and creating that multi-chain experience.
Yeah, so there's two parts of latency that aren't talked about as much. The first, obviously latency, ping time, we all know what that is. That's the round trip time to get from one place in the world to another. The piece that gets talked about less is jitter. And jitter is basically a measurement of how much that number changes over a given period of time. So you may ping from, here to New York, and you may get a number of 240 milliseconds. And you may hit it again, and it's 180, and then it's 390, and then it's back to 220. That jumping around of data creates a lot of indeterminism. And this is something that like TradFi learned a very long time ago. If you look at Jump or DRW or Citadel or any major traditional financial firm that's doing anything remotely high speed, they're using dedicated connections, not fiber at this point. They've mostly graduated to shortwave and microwave, but they're using these technologies because they always have the same amount of latency and they have basically zero jitter. And what happens in crypto, and this is where like, you're like, why jitter and latency? Why are we talking about this about like retail users? Well, spreads on crypto are big. Right. And they're not just big because it's an immature market that's volatile. They're big because there's a lot of risk to market makers. There's a lot of execution risk because you don't know when you send a transaction in on Solana, is it going to be filled in the beginning of the block? Because you got to remember on Solana, there's shreds. And so on Ethereum, like, or any EVM chain, the block is built basically at the end, at the last moment a validator could conceivably build the block, or it's built by a MEV system. But on Solana, like, it's 10 to 15 milliseconds, every shred that goes out, those shreds are basically pre-confirmations, if you want to use the church Latin from the Ethereum world. Like, those things are locked into the block, and unless the full block fails to finalize, which, really doesn't happen, or if there's an invalid signature in or something, that ordering matters. And so if you get to the block in the beginning versus the end, you will not only be in a different place in the block, but the data you are trying to write to, the state you're talking about, may have moved already. So if you're trying to do something like you're a market maker trying to make sure you don't get picked off when a price moves, you need to be at the beginning of the block, not the end of the block. And there's some blockchains that are actually playing kind of games with this, like they're putting all the cancels at the very beginning of a block. There's a lot of problems with that. The main one is you can't prove they ever got the data. So like you can't slash a validator for packet loss. But there's a lot of these types of things where when you get markets moving more quickly, when you get blockchains moving more quickly with less latency and less jitter, you actually get better price outcomes on chain for users. Oracles can get updates in faster, but also execution occurs more quickly, and things like cancel orders get in more quickly. And all of that leads to the type of extremely tight market spreads that you see in TradFi. There's a lot of hate for like HFT firms, but really what they do is they're reversion to the mean, right? Every time price deviates a little bit, there's a lot of money to be made in getting it back to the correct price as quickly as possible. And that is the dynamic we would like to see in crypto, because even if you're paying like 30 basis points of slippage on like a DeFi app, that's an atrocious amount of slippage. No one should be paying that much, but you have to because of the dynamics that market makers have to deal with indeterminism on chain.
To follow up on what the other two panelists just said, one, I do think that it is still true, unfortunately, that it's very hard to persuade Solana devs to get out of the Solana ecosystem. However, we are seeing some sort. So we started with a different approach. We wanted to get liquidity from the Ethereum or the mainnet, the EVM landscape to Solana, which helped a lot because now that we have liquidity on Solana, it's easier for us to convince them that you also want to get your liquidity out. And on what you mentioned on the market makers and the HFT firms, I sort of disagree because with an intent intent-based bridge or solver-based system, if the source chain is on EVM, on the destination chain, the solver will not care about the pre-confirmations. However, it will care if it goes the other way around from Solana to the EVM, to any EVM.
It just depends when you're reading the state, but we should just be honest that intent-based protocols are just called brokerages.
They don't like to be called that.
I know they don't like to be called that, but these are just smart contract brokerages, and usually 3/4 of it has nothing to do with a smart contract. It's just a centralized broker in the back end submitting a quote.
Yeah, this industry has this talent of...
There's no AI in that, though.
Not yet.
Okay.
But there's a new one coming.
Great.
Yeah, so to have a conclusion here for us, the low latency, it's also very much about the actual liquidity, which it doesn't affect us in a direct way because we use different type of bridges, and on the destination chain we also aggregate and we don't pick winners like a certain DEX or a certain DEX aggregator. So whatever the fastest liquidity is, that's the one that is most important for us. Fast and secure manner, obviously.
Yeah, when we think about the whole idea of latency on blockchain, it's very different of the idea of latency on, let's say, the NASDAQ. When you're dealing with these classical centralized exchanges, you could actually think about them as a single trusted, secure sequencer that you don't have to worry about when it's going to land, as long as it's a fair game by that sequencer and nobody's actually trying to manipulate, let's say, your trade. The biggest issue we have with latency on blockchains is the sandwiching attacks and people actually running dark pools or mempools to try to target poorly formed transactions to maximally extract from either novice users or from real intent to things that the user has technically signed off on to maximize draining their wallets as much as possible. What this really comes down to is these apps that are very technical and advanced trying to build around it. And I don't know if anyone here has built GMX. Anyone's used GMX, traded GMX now? Well, nobody in this room? Oh, 3, 4. There you go, 4 people. Okay. Well, I would actually recommend they do it because they have actually implemented a very interesting system for protecting against these risks of latency. They actually do a system of a worst up price take, which they can check prices before and after a order is actually submitted or liquidated to make sure that either someone's not trying to manipulate their entry price or the liquidation price, and can ensure that even after this liquidation occurred, there is some maintained state that nobody's trying to sandwich around, at least in a single block. So really, it comes down to the fact that as long as your transaction is pending, your transaction is sitting in a room of essentially adversaries because it's public. So how can you maximally protect yourself against adversaries when you have a transaction that is a money order that is sitting in this room that people, either validators or people that are submitting through some relay that they can try to beat you, can try to affect? So it comes down to building systems that either cannot do this, and unfortunately, the best solution right now is that a lot of chains do is some sort of centralized sequencer, which you can see Flashbots is a very popular one. It's not exactly unfortunate. I think they're a very cool product, and I'm a big fan of TE tech because we build on TEs for confidential compute and provable confidential compute. But it would be better to have a real, true decentralized system that was fast. And I know some chains, like some of the Solana L2s, are trying to say that they actually have such tight block times that they resolve this issue. But it's not really the block times that are the issue. It's the time that your transaction is pending in flight that people might try to malicious the CPAC. So yes, it's still a bit of an unsolved issue. I think making sure that data can be in the same transaction as a user is critical. And also at least sampling before and after to make sure single slot sandwiching is not part of this issue for as long as the user transaction is pending. Or confidential swaps, another solution.
And maybe building on that, right? The order of execution inside blocks. I think SIMD 96, with validators getting 100% of the fees. There's a lot of talk on how it helps remove any side deals and all. So how is 96 impacting like each of your projects, starting with you, Mitch, like how you build it, how you operate it?
I think it's a lot more fair game for competing with other sequencers like the Jito sequencer and how they work. And if it was up to me, I actually think I know there was an article at one time from FireDancer saying that they might actually offer a plugin store of people allowing different types of sequencers to compete for the best one. I thought that was the coolest idea. And I'm really sad that they actually ended up not going with it. I hope that they do bring it back one day, because you can have a whole different dynamic set of apps that might try to do these provably confidential sequencers, so you don't have these sandwiching risks. So maybe your transaction in flight is still confidential to other people in flight, even the validator itself. Maybe some homomorphic encryption scheme. I know Arcgame is working a lot of hooks around this. Maybe there could be something built into the validator, although I know it's very slow. But maybe I'm thinking hopefully. But I would really like to see a whole suite of different types of sequencers come to Solana, and at least MD96 makes it a more even playing field for native priority fees with some of the loved solutions like Jito's brought.
From our perspective, we do like predictability a lot, and having this new fee module on Solana adds us, I mean, it adds, a bit of more complexity for in our smart algo routing. However, we can now take more, things into consideration. So it's not only, gas, speed of execution, and also the trust spectrum when we do consider which bridge to recommend to the user based on all the others. And now the fee part is also an important one that we do need to take into consideration. So all in all, and in short, I do think that in the short time it's gonna be a bit complicated for us to adjust to it, but on a long enough time frame, I do think that it's net beneficial for Solana.
Yeah, I like pushing all of the data for that on chain, all the value for that on chain. We also take a percentage based fee model. So, of course, I like that. There actually are a huge amount of mods going on already. There actually are basically app stores for sequencers or modules that plug into FireDancer or the Agave code. They're all dark at the moment. And so there hasn't been someone who's like aggregated a store for something like that, but there's a lot of those types of things that exist. There's alternative relayers to Jito that exist. Many of them are parasitic. But I think like at a higher level, like this is an offense versus defense game, and offense always wins in these types of games. And so I think we have to be honest about what we're trying to solve and what realistically we can, because there's kind of like a few like philosophies here. The first is you try to minimize as many externalities as possible. The second is you just make everything so fast that no one cares. Right. And so like you do actually, it is harder to perform sandwich attacks if things get faster and data rates go up, because decoding data and doing the transaction simulation actually takes a lot of time. And so if you can just throw even more capacity at it, the validators lose incentives to do those sorts of things because they'll get penalized in other ways. And so defense is important. We should still keep working on that. But there's sometimes this like, I think like the Ethereum ecosystem made this trade-off in very much the wrong way, where there was so much sort of focused on what theoretically could possibly be a thing that we need to build before we could ever look at scaling something. And that's been the last 5 years of the L2 roadmap that like has not gone swimmingly. And so I think that that's like, we should think about these things, but really it is just about force more throughput through the system. There's less time for folks to decode things parasitically. That doesn't work forever, but anytime the problem with all these systems is like TEEs don't work in blockchain unless you control the nodes, right? Like the entire secret network was decrypted because SGX was cracked, and like it existed on all these decentralized places. So unless you're running proof of authority systems, it's really hard to actually have durable security through these systems. The cool things you can do with TEEs are like verify that a software package is legitimate. But the minute people start doing custom schedulers or custom mods in these systems, you kind of break the ability of the TEE to actually verify it, because 90% of people are not running like stock Firedancer or stock Agave or stock Jito. They've done all these little performance tweaks to it. And maybe that performance tweak is as little as they've prioritized their own customers on their RPC servers over other transactions. But it's a good move that we're starting to see more sort of assurances come into it. I just like, my constant reminder to folks with this stuff is like, make sure it's real and make sure it's not just security theater, because like security theater is like not worth anyone's time, I think, for the most part.
Oh, Rachit, Mitch, you had.
Yeah, I think 3 things there. Number 1, I would love to see that plugin store. I want to see who's building there.
Me too. I haven't seen it.
You
I
know
just
the
know it
secrets.
exists.
Okay, well, get me on the secrets. Number 2, I was worried about the increase in speed solving this issue overall. I think it would just focus possibly validators either to upping their infra game for, I mean, you can raise, the compute level of any infra that you're actually running for a machine, tenfold, and still try to extract max value, and just makes it more concentrated for the people who have those resources. And 2, even if to part B, I think that even if you increase those speeds for block time, you're just going to narrow down the scope that they're targeting to the larger and larger transactions that people might feel safer and more comfortable committing to. And 3, yes, I actually do think TEs for any historical state is a bad idea. Secret network as the perfect example, actually. I don't think that a TEs should ever be used for a permanent, secure historical state. But for something like secure execution, for a network that's like Solana that's updated maybe every few months or so, is probably a better solution for creating a safe environment for these trades. For now, I actually cannot think of a better solution to protect those types of large types of trades from being sandwiched by some validator that's really trying to target it. And I think if they could really give their effort, they could. And I know TE is perfect. I very much agree. But I think until we have those better solutions, you can give a lot of confidence to making sure people's trades go through in a secure manner, at least.
Got it. Giving a very left curve approach on this one. The whole proposal is if you give back 100% of the fees back to the validator should be incentivized to do it quicker, right? And it would eventually help with lesser congestion. So on the Wormhole side, we work with a lot of, since our solver-based network is based on Solana, a lot of people who are building these solver networks who are not familiar with Solana development struggle to land transactions on Solana, right? And during congestion, that just becomes a lot more harder. So if this happens, we'd probably see, newer devs coming in who would have a better time building on Solana, for instance. That's probably my bull case.
Cool. And so maybe like I know we are coming to time as well. So maybe throwing it back to you, Rohit, again, starting from you, like hottest takes. Like what according to you is the hot take for infra on Solana at the moment?
I think Solana is the infra for institutions. And, I spent a lot of time in Hong Kong. My team member Sushant spent a lot of time in Japan. We met with a couple of banks, and all of them asked us, when is the first big Solana institution announcement coming on? I think that's probably going to happen very soon, and we'll see a shift coming towards Solana and institutions.
Yeah, people don't give Solana enough credit for fully deterministic transaction execution. So a transaction has to specify all the accounts it wants to talk to before it can execute. And EVM transactions can go any which way. There's cool side effects like flash loans you can do from that. But Solana's transactions are actually a very strict format. And there's a ton of advantages for parallelization and also like safety for institutions on these types of things. And so I think we'll see people paying more attention to that in the future.
My hot take is that Solana doesn't need more bridges. Solana needs better liquidity abstraction, and that comes from a heavy DeFi user from the EVM landscape. And I can tell you that that's what most whales want when they want to park their money on Solana, and they want that.
I would say I think Solana needs to maintain being aware of institutions might try to do a max value extraction over these DeFi communities. And I think there's a lot of apps that directly connect DEX volume to CeFi. I don't want to like go over specific applications that might try to extract value out of the chain, but I want to make sure that value maintains its state in these ecosystems on these networks instead of going back into very specific institutional hands. So protecting users in that ultimate state. And overall, for the architecture of the chain, I think there does need a revamp. There is a revamp needed of how write locks work, given that anyone can actually try to maintain a write lock on specific wallets or specific AMMs to degrade someone else's experience while they get a trade in before them.
Yeah, just to clarify that, you can basically Shanghai attack a piece of state on Solana if you're familiar with that on Ethereum. And that's where the Oracle updates on push oracles came in from.
Awesome. I think we are also on time. So thanks, guys. It was a great discussion.